for this whole unit, we're going to study how populations change and what factors cause that change, and study the changes with graphs and charts and information. So there's limits to population growth, of course, and you could divide those into two categories. Dependent limiting factors, which means these factors are dependent on the population, or the population is dependent on that factor. And I know that's kind of like, what? But you're dependent on certain things for your population to grow. That's an easy question. Give me an example of one.
Food.
Food. What do we call food in this class? Resource. So limited resources is definitely going to affect population. Oh boy. Or abundance of them. So resources in general, even though I put limited because we're talking about limiting factors. What else can affect the population? Look at my pictures.
Wow.
Disease. Good.
Natural disaster.
Disease will affect you or wipe a population, and it's also dependent on you to thrive in some cases. What else? Let's stick to density. Is a natural disaster density dependent? No, it's independent. Good, because it's going to wipe a population, but it's not dependent on it for it to occur, or you're not dependent on it. It just takes care of it. What?
Reproduction.
Close. Reproduction. Yes, but that's not a factor. I mean, I guess it is.
But that would probably have to go with disease.
Yeah, it's a
Or
problem.
like genetic mutation.
Predation or competition.
Oh, I say competition.
I was thinking that, but then I was like, limited resource.
True. Another organism is a limited resource. So besides natural disasters, you could have fires, and you can also have any kind of clearing of a habitat. Is not a density dependent factor, but definitely will affect the population. Populations grow, shrink, stay the same. So let's continue to talk on what affects these. There's two main factors to consider when you think of growth rate. And we're focusing on this unit from now until the end on human population, okay? Because we already did populations of all different other kinds of organisms, so we're focusing on human. What affects our population, or I'm sorry, our growth rate? What's the formula?
Birth, life, death.
Birth minus death. You take all birth, you subtract from death, and that gives you your rate of growth, okay? In what way does our population grow? Exponentially. And what kind of curve is that? J-shaped curve, okay? Now, what do you think led to this population growth?
Technology.
Industrial.
Good. Industrial Revolution. What part of the Industrial Revolution led to growth? Good. The fact that we discovered things and how to cure things led to the increase in growth rate. So what part of the formula do you think was greatly affected by that?
Okay.
Death. Good. So before death, what caused the other part of the formula? We're going back to practically chapter 1. Education. That's pretty much there now. Going to change the whole curve. It's interesting how the curve can continuously change. What else? What led to the first shoot of growth? Before the Industrial Revolution? Agriculture. The ability to farm. The fact that we could move into a habitat, then farm and grow food, and then discover cures is the main three reasons for our rapid growth rate. So this shows your J-shaped curve and the growth of the population, of the human population, and the exponential growth. And you see that the majority of the growth, I mean, literally in 10 years, the population doubled in size. So there's some serious growing. And they estimate by 2050, there's going to be 2.4 billion additional people in the world. So you don't have to know every single part of this curve or what year, how many people are, but you do have to know that we currently have how many? 7 billion and growing, yes. All right, so let's ask ourselves this question. Will growing populations cause increase in environmental stress? And we're going to go one by one. And okay, so infectious diseases, why yes?
No.
It'll spread quicker.
It'll spread quicker. If you're a densely populated community will have disease spread faster than a population with a large amount of people but not so close together. So density takes a big factor into infectious disease. What about biodiversity loss?
Because we keep growing and there's more of us, we're taking away from the environment.
Good. Our growth takes away from other organisms' environment. What else? I want to spend a little bit more time on this one.
Like fish farming,
Why?
because we're making the same like fish over and over and over. So there's-
Genetically modified organisms. As we grow in a population, we have to figure out a way to feed the world. So we are growing specific types of species to benefit us. So we're limiting genetic diversity, and in the end is going to cause big problems and loss of diversity. Water shortages. Yes. We don't even have to say why. Traffic congestion. Yes.
Which we have,
Pollution of the seas.
of course,
Climate change.
there's no more COVID estimates.
So, who could tell me why I didn't even have to go over these one by one?
Because it's already happening very frequently now.
Can I say?
Yeah.
Overpopulation is the leading cause for environmental issues.
Because overpopulation, which I tell you in the first chapter, is the leading cause to all environmental problems. So at the end of the day, we know that overpopulation is the root cause of all these problems. End of story with it.
Mr.